Hello, I'm Joel Siegel, the Lab Director for Liberty Oilfield Services. I'm here today to talk to you about the ICP-OES. The ICP-OES stands for Inductively Coupled Plasma, Optical Emission Spectrometer. That's a lot of words, but really it's quite simple. An ICP-OES is a type of spectrometer that can be used for elemental analysis. We use our ICP-OES as the primary tool to check for a variety of elements in oil-filled waters. It allows for simultaneous identification and quantification of trace metals in aqueous and/or petroleum samples. The technique is mainly used to test for metals in liquid samples down to parts per billion detection limits. As the name suggests, the ICP-OES consists of two defining components. ICP stands for inductively coupled plasma. Yes, plasma is used as a source for the spectrometer. Plasma is a state of matter that is formed at very high temperatures. In our ICP, the temperature of the plasma is approximately the same temperature as the surface of the sun. In practice, the liquid sample is first turned into an aerosol. Then the sample gets injected into the plasma torch. The plasma torch ionizes or breaks the sample down into its individual ions or atoms. These atoms are in an energized state, and they will eventually return to their lower energy state, releasing some light in the process. The wavelength of the light emitted is related to the type of the elements, and its intensity is related to the concentration of the elements in your sample. The second defining component of the ICP-OES is the optical emission. Optical emission refers to this light created from the atoms returning to their lower energy state. Each element present in a sample generates a unique emission spectra, contributing to the light being generated at the torch. This light is then split by a diffraction grating, acting as a prism to divide the light into discrete emission spectrums. The wavelengths and intensities of these spectrum are then measured by the detector and converted into the various elements and concentrations. What do we typically test with our ICP-OES? We're able to test pretty much any type of water for just about any element in the periodic table. We generally test oil-filled waters related to hydraulic fracturing, such as frac source waters from lakes, ponds, rivers, wells, wastewaters, and municipalities. We also test flowback waters and production waters. As an example, one of our current methods allows for quantification of 21 separate elements in produced waters. I've listed the elements on this slide. It is also possible to customize additional elements to the method should you desire to see something specific. How do we utilize the data from our ICP-OES? The information that we get is often used to predict the likelihood of downhole scaling from frac operations. To do this, we combine the ICP-OES data with data from a few simple titrations done at or near the wellhead to make a more complete water analysis. The full water analysis can then be input into licensed software that is used to predict scaling of a single water or of a blend of two or more waters. The blending of waters can be simulated at various temperatures and pressures. For example, if you decide to use produced water as your frac source water and you want to simulate what might happen from a scaling perspective as frac water mixes downhole with formation water, and then as this mixture flows back uphole during flowback. The software can also be utilized to predict minimum inhibition concentration of a variety of scale controls. Cost performance comparisons provide a useful tool for minimizing treatment costs and dosages. In summary, the ICP-OES is a valuable tool for analyzing oil-filled waters as they relate to hydraulic fracturing. The apparatus saves time in resolving multiple elements of the periodic table simultaneously down to part per billion levels. This information can be utilized to predict scaling tendencies and to select scale inhibitors and their concentrations. For more information, please visit libertyfrac.com.